Hello and welcome back to Tech UK's stage at CogX 2021. My name's Sue Daly. I'm Director of Technology and Innovation at Tech UK. I'm really thrilled to be here for this next session, which is talking about high tech and hard tech and the road to net zero. And I'm joined for this session with a brilliant speaker who's really going to explore what this means. Paul Stein, CTO of Rolls-Royce. Paul, brilliant to have you with us. Thank you so much for being here.
Thanks very much, Sue. It's great to be here. I joined CogX a couple of years ago. It's a fantastic festival. So I absolutely am delighted to be back.
And in person, in the flesh as well. It's great to be here, right?
It's great to be here. It's great to have the interaction with you. And there's something missing when we do everything online, but we're doing our best.
Yeah. Now, I'm really, really thrilled that we're having this conversation because we're both obviously really excited about innovation and technology, and particularly in terms of the enormous challenge that we face with net zero. But also, you know, I'm coming at it from a Tech UK, so we're looking at the digital innovations, the technologies. You, of course, are also, but you're working within Rolls, working within a kind of traditional hard tech sector, really. So I think we're going to spend a bit of time today talking about where high tech and hard tech need to work seamlessly together to address some of these issues. But I've got questions for Paul, but I'm sure people out there might do too. So please use the Q&A function, raise questions as we go. I'm sure that we'll make some time for some questions at the end, Paul.
I hope so, Sue, yeah.
But let's kick us off. And as we said, you know, the road to net zero is such an important issue, right? But it's such an enormous challenge that we're facing, but one that we have to get right. And we know this from a Tech UK point of view and industry more broadly. And I'm obviously, in my role, work a lot with the innovators, the people developing the digital solutions and the technologies themselves. But I'd be really keen to get your views of what are some of the key emerging and transformative, you know, innovations and technologies that you see is going to be key to the decarbonisation challenge, perhaps, you know, for industry, but, you know, particularly perhaps in the aviation industry, given where you're coming from.
Yeah. Well, I think the first thing we all have to say is this is an enormous challenge.
Indeed, yeah.
It's probably one of mankind's biggest industrial challenges. Right now, the world produces about $4 trillion a year of coal, gas and oil. And one way of thinking about the net zero challenge is every dollar of that $4 trillion, and $4 trillion with a bit of price escalation is about twice the GDP of the UK. So every dollar has to be repurposed. We have to broadly stop digging up fossils and find other energy, net zero energy sources. So this is a huge topic, and one, as we know, where high tech and hard tech have to work together. You know, ultimately, hard tech has to produce the equipment, has to produce all of the huge facilities that are required to do this. And then the high tech world is going to facilitate that in an ever more innovative way. And we're going to be talking about that in a while. So when we talk about net zero, the main areas we talk about are energy, transport, and the built environment. Those are the big chunks. There's other things like agriculture, but generally we talk about energy, transport, and the built environment, all of them currently fueled in part at least on coal, gas or oil. So that means finding new net zero energy sources. So we're spending a lot right now on wind and solar, and have to start ramping up other technologies, nuclear and low cost nuclear, which I'll come back to, and carbon capture and storage. We have to place some future bets. So things like nuclear fusion, which, you know, maybe is a little bit sort of a little bit longer term, but we have to try and accelerate work on that. And things like energy storage. You know, we don't have anywhere near enough energy storage to make wind viable beyond a fairly sort of modest percentage of the grid. So that has to be accelerated. And then we need new energy vectors. So when you've produced the energy, you've got to carry it to where you need. So things like hydrogen and synthetic fuels, e-fuels, which I'll come back to in a while. You know, and then you mentioned aviation. There are one or two sectors of the economy which are hard to abate. And it's got to be said that aviation is pretty difficult. And it's difficult because, you know, for the last sort of 100 years, we've been using kerosene. Kerosene is hugely energy dense, and people have come up with all sorts of novel ways to propel aircraft to replace kerosene, but unfortunately very few of them have actually got the reach in terms of energy density that kerosene has got. So in aviation, we now have a plan to get to net zero by 2050, but it involves a lot of technology in three main pillars, we call it, and that's improving airframe and engine combinations, because we need to squeeze every last percentage of efficiency out of those. We need to ramp up what's called sustainable aviation fuels. So that's a new type of kerosene, same as diesel in cars, really, same basic chemical formula, but where the carbon comes from non-fossil sources. And there's a number of ways of doing it. Again, we'll talk about that in a bit. And then we have to explore novel propulsion. So people talk about hydrogen electrification, talk about hybrid electric. Again, we'll come back to that if we can in a while, but they're going to be part of it. So all of that together, then with a digital wrapper around all of it, in the way that we design, the way that we make, the way we support all of that ecosystem's got to come together with all the latest digital technology to drive us to net zero.
It's a lot to do, Paul, but we can do it, right?
Yes. You know, it can be done. You know, the world has to get onto sort of campaign footing to do it. You know, all of the governments have to commit firmly to net zero target. We're delighted that we live in a country that has put into law our need to get to net zero by 2050, but other countries are falling into line, and the US and Korea and Japan and France and others have done the same thing. So, you know, the world has to work together, and we can do it.
And I think, you know, when we were talking before, topic of this kind of fireside chat is hard tech and high tech working together as well, and coming together, right, as part of the solution. And we as Tech UK, obviously, we look at different technologies, whether it's, you know, we've talked already today about cloud, edge computing, we work on IoT, work on AI, which is talked about AI. But digital twin technology is one that we see is really, really key for not just this issue, but for lots of the challenges that we're going to face going forward. And how do we make sure that we get that right for the UK? And one of the things that we've seen is huge potential in digital twin technology, but you've got to be able to bring it to life, right? You've got to be able to show what it can do and how it can help industry, because that's part of getting people excited. It's about building trust and also, you know, adoption and use of digital twin technology. I wondered if you would agree, and if there are examples, particularly around digital twin technology, that you've seen or uses that you think really bring this to life.
Yeah, I think the you know, the use case I'd like to tell you about. In fact, I'll tell you about a couple of things. A sort of latest generation jet engine, but the one that I'll start with is an unashamed plug for our small modular reactor. So
I'll allow it. Go ahead.
Thank you for that. So, you know, at Rolls-Royce and with some other consortium partners, we've been putting our heads together to see how we can help accelerate this race to net zero. And we know that nuclear power has got to be part of the mix. I know there are many people that would like it not to be, but so far all the models say we have to have quite a large component of nuclear power in the mix. The problem with nuclear power to date has been, whilst it's sort of zero carbon at point of delivery, it's been quite expensive. And it's been expensive because of the concept behind the power stations that have been put together today. And we need the big power stations we've got today. But now it's time to move on to a new type of power station, which we're calling the SMR. And the SMR really is taking all of the tricks that Industry 4.0 and digital twinning has got to offer and creating a power station in a factory-built environment, rather than building it as a big sort of building site on site every time.
So MSR stands for?
SMR, small modular reactor.
Thank you.
So, for example, in the design of the SMR, you know, the entire design has got a digital twin. In fact, right now it doesn't have a physical twin to the digital twin. So the entire power station, the sequence of assembly, there's 3 million parts to each power station. Every part has to be codified. Every part has to go into a big 3D model. The 3D model then has to be tested in various ways to take it through regulation, like seismic sort of tolerance. We have to test the assembly sequence, and all that sort of thing is necessary to sort of expedite a low-cost solution. So without the sort of high-tech robotics that we're using in the factory environment, and the project's just starting. So, currently we're working with investors, with the government to sort of get this moving, but without all of the tricks that the cyber physical world has got, including IoT and robotics, methods of doing welding where you don't have the welder at the point of contact of the weld. This sounds a bit boring, welding, I'm sorry. But in the world of nuclear, welding is really important because every single weld has to be quadruply checked.
Absolutely,
to make sure it meets the right standards. So those kind of techniques are necessary to make it all happen. So, and then of course, simulating the power station concept itself, and then simulating the use of the power station with some applications. And one interesting one I'll mention, because it's I'm in a digital conference here, is the latest generation of data centers are up at 400 megawatts. So that's the power of about a town the size of Leeds in the UK.
Wow,
400 megawatts is a lot of power.
Yeah.
So we've been sort of simulating how you can connect a small modular reactor to a data center to get effectively a net zero data center, which we're going to need, of course, as part of rolling out the internet moving forward. So it really is kind of a genuine sort of coming together of hard tech and high tech, both in the design and the manufacture, and in some of the use cases that are opening up. So all exciting stuff.
That's great, because I was about to say, digital twin technology or IoT or AI or data center technology, it is really important for this, but it's not the whole answer, right? It's not only that on its own that is going to, get us to where we need to be, if I can say that.
You need to cut some metal. We need chemists, we need physicists, we need aerodynamicists, we need everybody. This is a community that has to work together. And
so collaboration is really important. So I suppose, if I can ask a question, because it's really good to challenge our industry as well as others, are we getting this right, or are there areas where more collaboration is needed, or we need to accelerate that perhaps?
I think we're getting closer and closer, but I think it's true to say, and I might be wrong, so this is a speculation on my part too, that if you like, the average digital engineer, the average AI scientist, have they worked in a factory environment and looked at the real challenges that a factory environment
on a day-to-day basis,
on a day-to-day basis? And if I take the average mechanical engineer or manufacturing engineer from my own company, how much do they know about AI, the capability of IoT, the capability of sort of digital parts tracking and workflow? And the answer is the two can learn a lot more from each other. So I think part of the answer is a sort of skills amalgamation a little bit more between the two. And then, of course, there's technology solutions as well. And there's no question that, as AI sort of forages its way into just about everything we do, the use of AI, particularly in the manufacturing environment, is ramping up and up and up. And we're starting to use it for looking at patterns behind sort of quality issues on parts and that sort of thing.
Because you mentioned about cutting metal before, and the kind of manufacturing process, of course, that, Rolls has got such a history and a tradition and a heritage in. And I wondered, this stage is all about next generation infrastructure and Industry 4.0. So I'd be fascinated, Paul, as I have you, if you don't mind me asking, are there, what tangible examples would you bring out of where Industry 4.0 is making a difference in the manufacturing? But you mentioned quality there. There's cost issues as well, right?
Cost and also in manufacturing flexibility. I think one example I like to give is we have a fan disk. I'll tell you what a fan disk is in a sec. So I know you're looking curious at me.
Always learn something new at Colgate.
Okay, so we have a fan disk factory in Washington, up in Tyne and Wear, up in the northeast of England, which we're very proud of. Fantastic workforce. And that has been kitted out with the latest Industry 4.0 equipment. So it's a full digital manufacturing execution system, coupled from the design people through to the factory in one hop. Now, these fan disks, they're the things that sit at the front of a jet engine, into which you slot the fan blades. Sounds very simple, doesn't it? But these things carry enormous amounts of energy. So an aircraft on takeoff, like an A350, one of the latest generation of Airbus aircraft, is pushing 53 megawatts through the fan, which is a lot of energy, quite a lot of energy. And so the tolerance that you have to cut that fan disk to is better than that, finer than that of a human hair. So in the past, it's taken ages to register up the fan disc on a cutting machine, run the cutting machine, check, do it. Now it's entirely digitized. So we have sort of robotized cutting machines, which can measure using structured light and using other methods the position of the piece in being cut. Then it goes through the cutting process, measures, cuts, and that pushes the yield right the way up. I can't tell you what the number is, but we're quite proud of it. It means the number of fan discs we have to throw away is very small. But better than that, if you want fan disc for one type of engine and a fan disc for another type of engine, the digital environment can quickly switch between different types of parts, which we couldn't do in the past. So not only has it improved the yield and hence reduce the cost by improving the quality, it's also increased our ability on factory flexibility. So that's to me, that's industry 4.0 really unlocking and at play.
It's fascinating because, you know, we talk about this as this is happening, right? This isn't just we could do this, we could apply this technology. It's happening in real life, of course. But what strikes me, Paul, is that, I don't know if you agree, that maybe 10, 15 years ago, this may not have been possible. It's really, you know, the acceleration and the convergence of different technologies to enable this to happen. It's really ramping up. Would you agree?
Yeah, absolutely. And, you know, and the acceleration is quite sort of palpable. Another example is 3D printing. Which 15 years ago, is this right? 15 years ago, 3D printing was sort of...
well, probably a bit of science fiction, right?
A little bit of it on plastic and that sort of thing. And now we're using it in production products. You know, and 3D printing, which, by the way, isn't magic. My head of manufacturing always tells me to make sure it's not like pixie dust that cures everything, but it's really, really useful technology for certain critical components that you can't make through other methods. And the beauty of 3D printing is the coupling of the design system straight down to the part to be made. Nowadays, you can buy sort of plastic 3D printers for use in your own home. The same basic principle applies, and all we've done is sort of scaled it up and applied all the aerospace quality that we have to it. So that's an example, didn't exist 15 years ago.
No, I mean, we saw, you know, even and every day the use of 3D printing last year or the last, you know, 18 months with the pandemic has really brought that to life in terms of what that can do.
Absolutely. And, you know, we were proud to be part of the ventilator challenge and produced sort of several thousand ventilators, which fortunately weren't needed. I think we were delighted that they weren't needed, ironically. But that couldn't have been done without additive layer manufacturing, you know, to rapidly sort of produce the scale up that's required.
And actually, even believe it or not, tomorrow we've got a session at this stage talking about 4D printing and the future and what that might lead to.
Wow, gosh.
But that's not for today. I mean, bringing it back to, you know, we were talking about the fans and the technologies that's enabled that to happen. Simulations, obviously, digital twins and simulation is really important. But just wondered, you know, how sophisticated are the simulations you're getting around, you know, energy usage and energy networks? Where do you think we are on that journey?
So so what I'll do is I'll come back if I can to jet engines, and particularly because there's some sort of very interesting ways in which the digital simulation world is touching jet engines. But to come back to your question, you know, when we talk about grid simulation, we're talking about ensuring that as we massively change this energy grid, so the energy grid, for example, the grid in the UK is you know, sort of combined of a complex set of wind and solar and gas-fired stations and a few coal-fired on standby and a few nuclear stations.
It's all different parts of the puzzle, right?
All different parts of the puzzle. And then coming off of the grid, you've got all the sort of standard uses like, you know, domestic electric heating or now electric vehicles coming on grid and industry and the built environment and this lovely building that we're in. And as we start moving more and more onto the grid, so as we move to electric vehicles, for example, we're putting enormous gigawatts of energy onto the grid. As we roll up the amount of wind, which is intermittent, wind in the UK roughly blows 30% of the time. So we have to manage that intermittency. So the role of digital simulation in making sure that every step of the journey is going to keep the grid stable and we're moving towards net zero without having to switch on those gas-fired and coal-fired stations is really complex. Actually, the UK is in pretty good shape. So I think there's a program called UK Times, which is done by UCL just down the road here in London, which is a pretty comprehensive grid simulation. In fact, it's an overall energy system simulation, but we need all of our digital brains behind needing to make sure that we're one step ahead of the physical world by simulating what's coming up for the grid.
Yeah. So interestingly, let's just look at obviously aviation.
Yeah.
Where you're CTO of Rolls-Royce, so people out there would probably shout at me going, wow, you're talking about aviation decarbonisation.
Yeah.
So talk to me a little bit about aviation decarbonisation. And I suppose I was about to say, does it just mean we have to fly less? I mean, obviously we're not flying really much at all right now, but in the future, you know, is that the solution? We just need to fly less?
So I'm going to give you a prediction that we'll end up flying more.
Wow.
And I'll tell you why in a second. Okay. I'll justify that.
I'm going to test you on this. I'm going to bring you back in a couple of years.
You can test if I'm not pushing up daisies soon. You can bring me back and test me on this.
You're on.
So in the world of aviation, obviously we take our responsibility to net zero as seriously as all the other sectors. Okay. Aviation pre-COVID. I'm going to have to quote all the pre-COVID numbers because aviation's been in turmoil, as you know, since the COVID crisis. Aviation pre-COVID was 2.6% of global CO2 use. So it's 2.6%. It's a very important 2.6% we take seriously, but some people that think you stop flying and the planet gets better, that's not what the data says. But how do we decarbonize that 2.6%? So we have in aviation what we call the 3 pillars of aviation decarbonization. There is a 4th pillar, which has got a digital aspect to it. So I'll mention the 4th one as well.
Thank you.
Yeah. So the first pillar of aviation decarbonization is we need ever better engines and airframes. Now, it isn't just a plug for my industry. It's because the cost of sustainable fuels is going to ramp up. And so we need to offset that cost to keep ticket prices down by making sure that we are using as less of it as we can. So my own company has got a concept called UltraFan. I'm not sure I've got time to describe what it is, but it's a next generation jet engine. So if you take a jet engine that powers the sort of latest jets today, like I've mentioned the Airbus A350 or the Boeing 787, so our engines that power that aircraft, UltraFan is a 10% step on from there. Might not sound a lot, but actually in aviation terms, it's a huge step. And a whole world of digital design and simulation has gone into producing that engine, which we plan to sort of ground test next year. I'll come back to that if I can in a while. The second pillar is where aviation and the energy world have to work together, and it's the ramp up of sustainable aviation fuels. So SAFs, as we call them, which actually is the same kerosene as you might need for example, agriculture. SAFs is a way of creating diesel synthetic sort of C12H26, where the carbon bit of that hydrocarbon doesn't come from a fossil; it comes from the atmosphere. Okay. And there's lots of ways of creating SAFs. You can create SAFs via what's called biovectors, where plants eat them up and then you create fuels from there. Perhaps the most exciting in the mid to long term is what we call e-fuels, where you literally suck carbon dioxide out the atmosphere, electrolyze water, and then use the carbon and hydrogen that comes from those two with a clever chemistry set and lots of energy from a nuclear reactor, in fact, our small modular reactor, to completely synthesize a fuel. So that's the sort of mid-2030s onwards. That's the way we'll go. The third pillar of aviation is what's often called the third generation of aviation, and it's the exciting world of novel ways of propelling aircraft. And we'll talk a bit about electric aviation, hybrid electric, hydrogen-powered aircraft. There's a world of new high-tech aircraft that's opening up, receiving a lot of funding, receiving a lot of excitement. And the reason why I say that I think we'll fly more is because I think the sort of the bulk of aviation as it is today will recover. People do want to fly, and aviation does connect the world. It's the only thing we've got, you know, for sort of connecting the world in a reasonable way since you know, the days of sort of taking a cruise liner to Australia and spending 2 months have long gone. But what's going to happen with these smaller aircraft, which are going to be electrically or hybrid electric propelled, is they're probably going to be more efficient and easier ways to connect city pairs than other transport modes. And that's why I'm confident that actually far from flying less, I bet you we fly more.
So brilliant, because I was going to ask you about Rolls-Royce Electrical.
Yeah.
Which, I mean, we all know Rolls-Royce, 100 years plus, such great heritage, such great history. It sounds like you guys are on a digitization journey as well, but I may be wrong. Tell me a little bit about Rolls-Royce Electrical and the vision behind it, because it sounds really fascinating.
Well, it is exciting. And so Henry Royce, by the way, was an electrical engineer. So we actually,
so back to your heritage,
full circle in the late 1800s. But so Rolls-Royce Electrical has been established as a business in a business within Rolls-Royce to provide all the propulsion equipment for this world of electric and hybrid electric and hydrogen fuel cell aviation.
Yeah.
So the idea is that we've been sort of creating an airworthy. So in aviation, we're always, safety. And, you can't just take equipment that's been developed for ground use and put it in the sky. You have to go through a whole different regime, quite rightly so, of regulation and certification. So it's a collection of equipment that we're selling to airframers, and I'll give you a couple of examples in a second, to actually enable this world of electric aviation. So one of them we're proud is in the UK, and that's a company called Vertical Aerospace down in Bristol, who have received a huge number of orders from Virgin Atlantic, from American Airways, and from others, to ramp up their what they call an eVTOL solution. So eVTOL is electric vertical takeoff and landing. So helicopters are going to be passé.
Wow.
And the next generation is a type of flying machine. They're often called flying cars. That's a bit derogatory. Think about it as the next generation of helicopter. Think about it, if you will, as the next generation of air ambulance, because it's something that can land in an urban canyon and perhaps, rescue somebody from a road traffic accident in the way that a previous one could.
Yeah.
And then there's fixed wing. So we're working with an Italian company actually called Tecnam to propel aircraft to offer a service up the Norwegian fields. So this is a full electric service, which they're hoping to operate sort of around about 2026. And this will sort of propel people across fields to the islanded parts of Norway, pure electric, fantastic sort of piece of technology, up to 270 kilometers on the battery charge. So, and again, we're going to see more people flying in Norway because it's just quicker and cheaper and more environmentally friendly than taking a ferry.
So I was going to ask you, touched on it now, I was going to ask you, paint me a picture, what the electrical or hybrid machines that we'll be seeing, and are we going to be seeing this, in the next 10 years? Is this going to, happen?
Yeah. So in the longer term, I guess we just need to keep emphasizing the jet engine isn't dead before I come on to, for those sort of medium to long range flights, we really don't have a solution other than jet engines powered on sustainable fuels, very efficient jet engines in efficient aircraft powered on sustainable fuels. So when we talk about electric and hybrid electric solutions, we tend to be talking about slightly shorter range journeys. So the vision that I can see in 10 years is, first of all, we'll see those longer range journeys powered in part by sustainable fuels. So IAG, that's the group that owns British Airways and Iberia in Spain, have now committed, and good for them, to a 10% blend of sustainable fuels by 2030. So those flights will start to use sustainable fuels, with that percentage growing and growing.
Yeah.
And then for the shorter range journeys, maybe in the Highlands and Islands in the UK, we'll start seeing fixed wing pure electric. Yeah. And then we'll also see these eVTOLs start to be used for sort of slightly shorter range journeys, but able to land in urban canyons. You don't need runways.
Yeah. It's really exciting.
It's an exciting time.
Yeah, it really is. And this, what would have been, science fiction, 20 or 30 years ago is becoming reality. And that's, to me, and I'm sure you're the same, that's what's exciting about being in this world of technology and innovation. And it's really, the pace of change is tremendous.
It is exciting. And coming full circle, we're doing all of this a little bit in aviation to unlock the utility of electric aviation, but it's really part of a net zero journey.
Yeah.
And that's why we're doing it.
Yeah.
And, it's interesting how net zero has been a forcing function across many industries. It'll force the combination of hard tech and high tech, which is kind of why how we started this talk. We couldn't be doing these electric aircraft without having very sophisticated simulations of how the battery system operates, the aerodynamics around the aircraft, the airframe integrity and all this sort of thing. And so it's just a very exciting time.
No, I agree. And also, as you said, rightly so, it's high tech. It's the technology industry and your industry coming together to look at, what is possible, the art of the possible. And really, this is key to achieving everything that we need to achieve going forward. How can we collaborate more? How can we do more together?
Absolutely.
Right?
We really can't make, design or operate our products without the very best in high technology.
Yeah. So we're coming up to, sadly, the end of our time, Paul, but we did have a question that came in. We're talking about, kind of innovation is moving, and innovation perhaps is moving east was the question. And this will have a, change of the economy and the national psyche. But I think the question is more, a kind of how do we keep our place in the world? How can or your view, I suppose, of how the UK can make sure that we keep, our place in the world and perhaps as a leader, which we have been for many, many years in this area. How are we doing, and what do we need to do going forward?
Look, so we're still holding our own. However,
which is great, right?
Yeah. However, sitting on our hands is not going to solve the problem. And in some ways, what we're seeing is the ascent of the East. Is that a bad thing? Maybe not, as long as we can all stay friendly and operate as one global community. But what a great forcing function, sorry to use that term again, for us to sort of switch up our innovation. And in the UK, and I'm speaking for the economy as a whole rather than necessarily Rolls-Royce, I would say we need to get more connected with our finance community. So, patient capital is there to fund all the great innovation we've got in the UK. We need to connect science and industry a little more closely in the UK. We're great. We're number one in science in many areas. I've got Nobel Prizes coming out of our ears, but we're not very good actually at transiting that science into sort of manufactured goods and exports or services and exports. We need to get government policy fully behind this and aligned with it, so that the government is there as a convener and maybe as a pump primer to get sort of new things moving. And for example, the UK has recently announced ARIA. This is the new Advanced Research and Innovation agency. Brilliant, and it's just one of these things that we need alongside many other things to sort of propel us into a more innovative future. No,
I agree with you. I think, in fact, on Thursday at Tech UK, I'm chairing a session on what they're not in place yet, but what the CEO of ARIA, when they do find him or her, what they need to do perhaps as they, get to work, and where should be the priorities and where should we focus. It's we've got ARIA now. What do we do with it?
Well, that's bang on. I would say though, your session, if you don't mind me saying this, it's more than the CEO of ARIA. It's actually the whole economy. All of us need to join together. I know we've got an international audience here, so I'm sort of saying this for the Western world. I'm saying this for the whole world, really. It's a case of connecting together, capital, innovators, science, governments, regulators, all working together to increase the pace of innovation for net zero and for other common goods for the world. I
completely agree with you. And also it's really interesting you bring up the kind of really good at the science, really good at the research. When I get asked a lot about R&D, and it's like we're really, really powerful at the R, and we're good at the D, but we need to make sure that we put the D into R&D. And it's not just, or may I say, it's R and should be maybe R and double D. It's research, development, and then diffusion. It's, taking that research into that kind of commercialization and development. But then also it's getting people to adopt and use them, right? We mustn't forget about that.
I absolutely agree. And, and as time moves on, for me, there are times when I think actually the solution isn't technological, it's more anthropological. And this is a case where actually I think, industry understanding academia understanding industry, and government understanding both is a time across all the Western economies when we have to work together.
Absolutely. We've just got a question, if I may, I think before we end, is Rolls-Royce is looking at battery technology with higher energy density. Forgive me, guys, if I look like I'm squinting. I forgot my glasses.
I'm squinting too.
Paul remembered his, okay. I forgot mine. which is specific to the requirements of electric aviation. Does that make sense to you?
It does. No, it does. It's a really good question, and thank you for the question. So, batteries are sort of great technology. They'll be in, obviously, definitively in every EV.
Yeah. Important for things like drones as well. It's
important for things like drones. We're looking to increase the energy density of them. We don't know how far we can go, but we have to be conscious that there's a lot of energy stuck in a battery, and it's potentially, a hazard waiting to happen. And if it's a electric vehicle where you're not sort of pushing the current you're pulling out the battery so much, and you're in a more controlled environment, the hazard can be managed. When you're in the sky, there isn't there's no hard shoulder at 6,000 feet. At least not when I looked last time. So it takes battery technology, or the need to monitor it, onto a different plane. So, for example, the battery systems we're putting into Axel. So Axel is our showpiece world airspeed record flight attempt, which we're hoping to fly about July time. Every single cell is individually monitored on that aircraft, and the whole approach to sort of managing the safety in terms of the thermal signature of the cells, monitoring them individually, the fire zoning, how you manage fires. It's just a different plane up from cars. So it's a very good question. You can't just take a car battery pack and stick it in an airplane. You can use the cells, but you have to sort of individually monitor the cells. A lot of AI, by the way, because we gobble up huge amounts of data as the aircraft is running, and the sort of algorithmic side of checking
and understanding what that data is telling you.
I think Axel's got 3,000 cells, all being pushed to within an inch of their lives to get that propeller running and beat that airspeed record. And to keep our test pilots safe, we have to make sure that they're all individually monitored.
Paul, your work sounds absolutely fascinating, and it sounds like it's a brilliant time to be at Rolls-Royce, and you're really at the cutting edge of figuring this out, and also bringing the two worlds together, and it's really powerful to hear. Thank you so much for sharing with us today and for being here, and really personally, and I hope you all enjoyed it too, but that was a fascinating conversation. Thank you so much.
And thanks for your question too. Thank you.
Oh, well, I'm sure if we're all watching, virtual round of applause, Paul Stein, CTO of Rolls-Royce. Thank you so much. But unfortunately, we've come to the end of our time now for this session. So it's up to me to wrap up. Go and grab yourself a coffee, go and grab yourself a tea. I should say stand up and move around if you've been sitting watching us. We'll be back at 4 o'clock on this stage to talk about quantum commercialization with Roger McKinley from Innovate, and Steve Briley, the CEO and co-founder or founder of Riverlane. So Laura will be back with you at 4 o'clock. But just on behalf of myself and Tech UK, again, thanks to Paul Stein, CTO of Rolls-Royce. And I will leave you there. See you all very soon. Bye-bye.